Hello and welcome. Today we'll talk about HashMap.
So what exactly is a hashmap? A hashmap in Java is a collection that stores data in form of key value pair. One of the main reasons why it is so popular because it is very fast. In fact, we can fetch data from a map in effectively constant time complexity. That means it's almost like already knowing where your data is and getting it directly without wasting time to search for it. But wait, how is hashmap able to achieve such speed and accuracy? Well, the secret lies in the structure of the hashmap. Before jumping into HashMap implementation, there are two functions you should be familiar with, hashCode and equals. These functions come from the object class, so they are available in all objects by default. The hashCode function returns an integer value when called. By default, it returns the memory location of an object. But when we override it, it calculates an integer value based on our own logic. The equals method is used to compare two objects. It either returns true or false based on the method implementation and object values. We can also override equals method to provide our own custom logic. A hash map internally consists of buckets, and each bucket is referenced by a number. Each bucket contains a linked list. We mainly perform two operations on a hash map: put operation to store data, get operation to fetch data. When we call the put operation to store data, we pass a key and value pair to the hash map. It takes the key and calls hashCode function on it. The hashCode function runs and returns an integer value. This integer value is used to decide which bucket the data should be stored in. Once the bucket is identified, hashmap checks if the bucket is empty, it stores the data there. If the bucket is not empty, it compares the incoming key with all the existing keys in the bucket by calling equals method against each key. If all the keys return false, it means that this is a new key and a new entry will be created for this particular key value pair. If the key matches an existing key, the value for that key will be updated with the new value. That is why it is mandatory to implement hashCode method carefully. A good hashCode method consists of even spread of data across all the buckets. This way, we need to make fewer calls to equals method, which is a linear operation. The implementation of equals method is also important to correctly identify duplicate values. If we keep the default implementation of equals, it will always compare the object reference. No two unique objects ever have the same reference. So equals method will always return false for different objects even if they contain same value. On the other hand, if we provide a weak implementation of equals method, then a lot of objects return true even if they are not equal. So both hashCode and equals need to be implemented properly. Now let's look at how data retrieval works. To get data from hashmap, we call the get method and provide the key for which we want to fetch the data. Hashmap again calls the hashCode method on the key and get an integer value. This value tells hashmap which bucket to look into. Then it checks each entry in the bucket one by one and compare it with the key using equals method. If a key in the bucket matches, it returns the corresponding value. If none of the key in the bucket matches, it returns null, meaning no value of this key is available. Now, what is hash collision and why should we avoid it? When we calculate the hash code for a key, it returns an integer value based on some logic. If two different keys return the same hash code value, this is called as hash collision. When a collision occurs, both keys are stored in the same bucket. This means that when we try to retrieve a value, the hash map has to compare the key with all the keys in the bucket one by one. This comparison is linear and it makes our search slower. If each key had a unique hash code, we could directly jump to the bucket containing only that key and return the value instantly. But when collision happen, we need to compare each key during both storing and retrieval. And here's the big problem. If too many collisions happen and all the keys end up in the same bucket, then for retrieving each key, we will need to compare it with all the other keys. This would take same time as searching in a list, and we would also be wasting extra storage without improving search time. That is why it is best to have minimum or no collision at all. In short, HashMap gives us fast access using hashing. HashCode decides where to store or look. Equals ensure we match the right key. And good implementation of both minimizes collision and keep operations fast.